element of real numbers and p is greater than 0 and less than or equal to 1. They are the clues given. So let's write down them. P is an element of real numbers. P is greater than 0 and less than or equal to 1. Show that 1 is not a root of the quadratic equation. What is the quadratic equation? P squared x squared plus 2x plus p equals 0. This is the quadratic equation given. So you know, if 1 is not a root of the quadratic equation, this quadratic equation should not be satisfied by 1. Right? That means if I substitute x equals 1, it should not be equal to 0. Let's see it. Right? When x equals 1, you know, p squared x squared means 1 squared plus 2 times 1 plus p equals 0. So you know this is p squared plus 2 plus p. Since p is greater than 0, p squared is greater than 0 and p is greater than 0, 2 is greater than 0. The sum is positive. It's not p equal to 0. So you can write that 1 is not a root of the quadratic equation. The quadratic equation. Okay. Let's move on to the next part. Right? Let alpha and beta be the roots of this equation. Show that alpha and beta are both real. Let alpha and beta be the roots. Okay. Then show that alpha and beta are both real. What should happen if alpha and beta are both real? You know that the discriminant of the quadratic equation should be greater than or equal to 0 if two roots of the quadratic equation are real. Okay. Let's see. Let's see the discriminant of the quadratic equation. So it is b squared, it's 2 squared minus 4. A is p squared, c is p. So this is 4 minus 4p cubed. 4 is the common factor minus this is p cubed. So you know 4 greater than 0 since p less than or equal to 1 and greater than 0. You know that 1 minus p cubed is positive. It's greater than or equal to 0 because it can be equal to 0. So 4 times 1 minus p cubed is greater than or equal to 0. Therefore, alpha and beta both are real. Both are real. Okay, let's see the allocation of marks. Okay, for finding this part, for the substitution, they had given 5 marks. For showing that, they had given 5 marks, altogether 10 marks for this part. And for finding the discriminant, they had given 10 marks. Showing this, they had given 5 marks. And for writing this, alpha and beta both are real, they had given 5 marks. Altogether for this, they had given 20 marks. Now, okay, let's see what will be the next thing that we have to do. Now we know know alpha and beta both are real, and you have to write down alpha plus beta and alpha beta in terms of p. Okay, you know the quadratic equation is p squared x squared plus 2x plus p equals 0. So you know alpha plus beta equals negative times of 2 over p squared, and alpha beta equals p over p squared. Therefore it becomes 1 over p. Okay, then show that 1 over alpha minus 1 times 1 over beta minus 1, this product is equal to p squared over p squared plus p plus 2. You have to show that. So first thing that you should do is to simplify this. You know this is a product, so 1 into 1 is 1. Here you have alpha beta minus alpha minus beta plus 1 when you get this product. So you can write it 1 over alpha beta minus alpha plus beta plus 1. Then you can do the substitution. When you substitute these values here, now look at this one. 1 over alpha beta is equal to 1 over p minus alpha plus beta is equal to minus 2 over p squared plus 1. So you can write it 1 over p plus 2 over p squared plus 1. Okay, then you can multiply both numerator and denominator by p squared. Let's see. Okay, then p squared over, and you have you can multiply both numerator and denominator by p squared. Right? Okay. Now p squared over. Now you know when you multiply these two, you will have p here plus. When you multiply these two will be cancelled. So you will have 2 and 1 into p squared is p squared. So we will have the answer p squared over p squared plus p plus 2. Okay, let's see the allocation of marks for that. For this part, they have given 5 marks. For finding alpha beta product, they have given 5 marks. For writing this in this way, they have given 5 marks. And for the final answer, they have given 5 marks. So altogether, 20 marks have been given for that. Okay? Okay, let's move on to the next. Okay. Now, you have these results. You found them in previous parts. Now let's see what is the next part. Show also that the quadratic equation whose roots are given, roots of the new quadratic equation are alpha over alpha minus 1 and beta over beta minus 1. Alpha over alpha minus 1 and beta over beta minus 1. So you have to show that the quadratic equation is, show that, right? Show that, this is the part, show that quadratic equation is p squared plus p plus 2 times x squared minus 2 times p plus 1 into x plus p equals 0. You have to show that. You have to show that. Okay, you have to show that. For that, you know the 2 roots, right, times x plus product of 2 roots. Product of 2 roots equals 0. This is the quadratic equation. So let's write them. X squared minus sum of these 2 roots. So alpha over alpha minus 1 plus beta over beta minus 1 times x plus product of 2 roots alpha over alpha minus 1 times beta over beta minus 1 equals 0. So for that one you have to get a common denominator. It's x squared minus alpha minus 1 into beta minus 1 is in the denominator. Let's see what is the numerator. Numerator is alpha times beta minus 1 plus beta times alpha minus 1. Then times x plus this one is alpha beta over alpha minus 1 times beta minus 1 equals 0. Now I didn't simplify it because we know the answer for that part, right? This is 1 over alpha minus 1 times beta minus 1, so we can directly do the substitution. Okay, this is x squared. Now you can bring brackets minus alpha beta minus alpha plus beta alpha means alpha beta minus beta over alpha minus 1 times beta minus 1 times x plus alpha beta over alpha minus 1 times beta minus 1 equals 0. Okay, now you can see that x squared minus alpha beta, when we can get the sum 2 times alpha beta minus alpha plus beta over alpha minus 1 beta minus 1 product times x plus alpha beta over alpha minus 1 times beta minus 1 equals 0. So you have to substitute values for these parts. Let's see how can we do it. Okay, x squared minus 2 times alpha beta, that means 2 over p minus alpha beta, alpha plus beta is minus 2 over p squared. Then you have alpha minus 1 beta minus product. So it's equal to 1 over alpha minus 1 over into 1 over beta minus 1, this product. These two are equal. So you can multiply it by it. P squared over p squared plus p plus 2 times x plus alpha beta. Alpha beta is 1 over p into, you can write the substitution for this product. It's p squared over p squared plus p plus 2 equals 0. Okay, then you can simplify for the expression which is inside of the brackets. You can remove brackets. P squared will be the common denominator there. So this becomes 2p minus plus. So it's plus 2 times p squared over p squared plus p plus 2 times x plus, this is cancelled, so you have p over p squared plus p plus 2 equals 0. So simplify it. now you have x squared minus 2 times p plus 2 over p squared plus p plus 2 times x plus p over p squared plus p plus 2 equals 0. Let's see what is the answer given. In the answer it's given that, when you take this outside of the brackets, this should be 1. It's a mistake, right? Okay, then this is 1, right? It should be 1. Okay. Then you can multiply the whole equation by the denominator of that. So it becomes p squared plus p plus 2 times x squared minus 2 times p plus 1 times x plus p equals 0. Okay. Let's see the allocation of marks for this part. Okay, for this part they have given 5 marks. High 5 marks. Then for this, for substituting this, right? They have given 5 marks, right? Then for this part they have given 5. Okay. Then for the simplification they have given 5 marks each for these 2. Then for this factorizing and all these, for this one they have given 5. For this part they have given 10. So for the final answer they have given 5. Altogether 35 marks have been allocated for this part. And that both of these roots are positive. That means alpha over alpha minus 1 and beta over beta minus 1 are positive. You have to show that. But how do you do? How do you do? You know, by finding sum of these two roots, if sum is positive and if the product of these two is positive, then we can decide that both of the roots are positive, right? Okay, let's see. Alpha over alpha minus 1 plus beta over beta minus 1. This is the middle term of the quadratic equation. It is 2 times p plus 1 over p squared plus p plus 2. You know, because p is greater than 0 and less than or equal to 1, the numerator is positive here, and since the same reason is there, denominator is positive. Both the numerator and denominator are positive here. So this is positive. This is positive because p greater than 0, right? Because p greater than 0. Product of these two roots, alpha over alpha minus 1 into beta over beta minus 1. What is it? It's p over p squared plus p plus 2 is also positive. It's greater than 0. Therefore, you can say that hence both roots are positive. Let's see the marks allocation for that. Marks for let's see. For writing sum and product both, for writing sum and product are positive. positive. 5 marks have been allocated here for that, these two. 5 marks. For showing that these two expressions are positive, they had given 5 marks, and for writing this answer they had given 5 marks, so total is 10. Then you can see for this part, for quadratic equations and quadratic functions, this part A of the question, they had given 95 marks out of 150 into 2019, right? Okay, let's see how to solve the next part